Hello guys, in this video we are going to see some series and expansion starting with Taylor series. So if fz is analytic at every point in a circle C having center z0, then for every point z inside this C, the function fz can be expressed as fz is equal to fz0 plus z minus z0 into f dash z naught. This f dash is its differentiation plus z minus z naught whole square upon 2 factorial to f double dash z naught and so on, which is also equal to n is equal to 0 to infinity and z minus z naught to the power n, where an is equal to 1 upon 2 pi I integration f t t minus z naught n plus 1 dt is equal to fn z naught or n factorial. So this is our required Taylor series. So we have expressed fz as a power series in a positive power of z minus z naught or about a point z naught. So let us assume z naught is equal to 0, which means we are talking about origin. So let's place z is equal to z naught here. f0 plus z f z naught plus z squared 2 factorial upon fz naught plus, and now this series is known as Maclaurin series. Thus you can see this Maclaurin series is nothing but Taylor series with z naught is equal to 0. So our next series is Laurent series. So let's start with fz. So if fz is analytic at every point within a ring-shaped region R bounded by two concentric circles C1 and C2 with center at z is equal to z0, then for every point z within the region R, the function fz can be written as this: summation n z minus z naught n is equal to 0 to infinite plus n is equal to 1 infinite bn z minus z naught minus n. So we have expressed fz in terms of both positive and negative power series of z minus z naught. Here an is equal to 1 upon 2 pi I integration ft dt upon t minus z naught to the power n plus 1 dt, and its area is C1, where n is equal to 0 to 1 to and so on. And Bn is defined as 1 upon 2 pi I integration, here region is C2, ft dt upon t minus z naught minus n plus 1 dt, where n is equal to 1, 2, 3 and so on. So here you can see this n is of positive sign and here a negative sign is present, and obviously here n starts from 0 to 1 and so on, and here from 1. So here are some standard expansion which you have to learn because they are very useful, not in complex variable but in other field also. You will find it easy to solve questions when you learn these expansions. So first it is e to the power z, which is 1 plus z upon 1 factorial plus z square upon 2 factorial and so on. Then 1 minus z to the power minus 1, and then 1 plus z to the power minus 1. Again 1 plus z to the power n. This is a general equation. You can use this to derive this or this. And then log 1 plus z is equal to z minus z square upon 2 plus z cube upon 3 and so on. Here you can see this, there are no factorial, and here we are using factorial. So this was all about series and expansion. Thank you.